Hey guys, what's up? Welcome back to Swats dudes. I know it's been a longer than usual since I've made one tutorial. That's because it's been a really busy month with a lot of works in my studio. Plus, I needed to test our rig with a couple of objects to really know whether it's working or did I just waste a month of mine. Well, I put one of the test renders in the YouTube shorts. I guess you've seen that. The awesome Hulkbuster render that I just finished in 8 hours. No? Okay, so now finally our basic look dev setup is ready. There's nothing fancy or advanced things in this rig. It's just a couple of lights with some simple plane and a character. And now you are seeing the results that I have achieved with this simple setup. So there are a couple of things that I use in this rig which I have already explained in my previous tutorials, like look dev rig with HDRI and constant exposure light in Maya. So I won't be explaining those things again in this tutorial. That will be so boring. So I have put the links in the description. Make sure you check that out. So one thing that I need to tell you is that this is a baseline rig, really a simple one. So I want you to explore more and experiment more on this rig on your own. So let's get started. So we are back in Maya. The first thing I am going to start with is a locator. So I'm creating a locator, changing its name to main_control CTRL, and I'm going to scale the locator to around 20. So all of the lights, meshes or anything that we create is going to get under this main control. So the main control is our main, like the name says, the main control of the rig. This is mainly used for adding any attributes. If you want, you can add attributes on this, or in the basic thing, we are just gonna use it to scale the rig up and down. So we are going to use the area lights with the constant exposure expression in this, so that it won't change the exposure of the lights. So we can easily scale the rig according to our asset size. So coming to the asset size, why we would have to scale according to other assets? Because in look development, if you are going to follow the physical accurate workflow, or you want physically plausible shaders, you need to look dev each asset on its actual physical scale. That means if you are going to look dev a human character, an average human character has a height of 6 feet or 5.5. So you have to scale the human character or make the human character in that particular scale. So I've already imported this character on here. So you can see I have already scaled this character onto a 6 feet dimension. And if you don't know how to do this, the simple way is, if you think the character is on any other scale, you can go to any orthographic view and just create a measure tool, distance tool, and you can just use the second locator tool and put the translate y into 180 centimeter. So this is the height, 6 feet height of that human character, and we can just scale it to that particular height. So make sure you model any of your asset on the physical scale. In some cases, there is a chance that when we are going to, like for example, when we are doing any city assets, like huge buildings that are very big in size, like 40 floors or something, that is going to be at like 200 meters or 300 meters in height, which is if you are going to, let's say, look dev a whole city or just a building, you won't probably be going to model it on that particular exact accurate scale. You will be then scaling down the whole scene scale into something 200 meter into some 200 centimeters or something. So in that particular case, you can use that size as a base unit. So it differs according to your need and the project settings, but mostly you are going to use the real world scale on most of these assets. So we have our asset. Let's just delete this distance dimension, and now we have our locator, we have our character. Now let's create a ground plane for the character. So I am going to scale this to 450 centimeter, which is 15 feet in length and width. So we need something as a room wall for the character background. So we are going to make that wall from our ground mesh itself. So I'm just going to select these edges and I'm going to extrude the edges onto a particular height. You don't have to scale it all the way up. It just need to be higher than this the height of the character, so that the camera will cover the whole ground plane and there will be no alpha on the render. So also we are going to bevel these hard edges so that the mesh will be smoother and there will be no hard edges on the render for the background. So I'm gonna add some segments on this, and now if we press 3, we get this smooth plane as a ground and also as the wall. And now we are back pressing 1 to remove the smooth, and we are going to delete the history of this plane by coming to edit, delete all by type, history. And in the plane shape, we are going to Arnold, and subdivision, we are changing the subdivision type to cat cloud. Also, I'm going to rename this as ground. So now I'm going to assign a gray shader onto the ground. So I'm just gonna do 0.18 on this ground, and I am not going to use any speculars on the ground because it's just for blocking the background and adding some indirect bounces onto the character. That's the whole purpose. We don't need any. It's better if we keep it as a matte object. We don't need any particular speculars on this. It's gonna cost to render time, and it's not necessary for us on the look dev. And next I'm gonna add the gray and chrome balls. So I'm just gonna import the gray and chrome balls onto my scene. So all these settings and the things are already explained in my other tutorial, look dev rig with HDRI. So check that out to know what the shader settings are and how we set up the chrome and mirror balls. Now let's add a camera. So I'm gonna go to create cameras, camera. So you can see this as the scene scale is larger, this camera locator is so small, so we can change that on the camera shape object display. You can scale the locator into, let's say, 20, and we get a bigger camera. And now I'm going to change the focal length into 85. You can prefer any focal length more than 50-55. I prefer 85 for this particular tutorial, but it's your choice. Just one thing is, don't go beyond 35. Even if it is a landscape, you can work with focal lengths more than 35. It's totally fine on look dev. We are not going to do any short lighting on this one. It's just, we just need to see the shader properties or shader parameters working fine or not. We are not going to see the aesthetics or like the perspective aesthetics on this thing. So we don't need to go beyond 35. I mean below than 35. So this is our render cam. So let's say if we are going to get some objects which are smaller or bigger, so when the object height changes, you'll have to move the camera and we'll have to move the camera aim into another position. So either we can adjust the camera freely like this, or you can create a locator and aim constrain the camera onto that locator, so that it will be easier. If the character is smaller, you can just move the locator down and the camera will focus rightly onto that particular character. You can adjust your frame according to that. So it's your preference. I'm not going to do any fancy things on this anymore. It's just simple setup, remember. So we are just making a basic setup of lighting and all those things. So our ground is now, you can see from the camera angle, there's a gap you can see on the sides of the plane. So to avoid that, I'm going to scale it on the x-axis, just the x-axis, so that the plane completely fills the camera frame. So now our basic object and camera settings are all done. So let's create our first light. So the first light I'm going to create is an environment light. So even if we are going to use area lights in this one, there is always a need for some fill light. Let's assume a situation where we get an object which is completely reflective, like chrome, like the chrome pole. So it reflects the environment which it is placed. So if there is only a plane and a 3 or 4 area lights on the scene, that is the only thing that is going to reflect on that object. And from the frontal side, there will be nothing for it to reflect. So the reflection is going to be black, pure black. We don't want that. And also there's a chance that there will be areas which are filled with very hard shadows. So in order to avoid all these situations, we are going to first add an environment light, which is going to act as our main fill light. So I'm gonna rename it as environment, and I'm going to add a texture onto it. So I've already created an image or a texture. This HDRI is from HDRI Haven, and you can see there is light information on this. So I've painted out all the light information from that particular HDRI so that it has only a bounce lights on it. So there won't be any particular shadows or hard lights coming from that HDRI. So this HDRI's job is just to provide enough fill so that no areas on the object or that particular frame goes to black. So I'm just gonna open it. So you can see it's just a flat HDRI. Now let's do some render settings. I'm gonna first put the camera samples into 4. Okay, first we are going to put the camera samples on the environment to 3. So this is a base light samples, because as this is a wide area light, it needs more samples to reduce the noise amount. So usually 3 samples does the job. And back to camera. For the start, I'm gonna put the camera samples to 4, rest of them to 1, 1. And right now we don't need any transmission or triplers. We don't have any objects which has a transmission or triplers on the scene, so we leave it as 0. And on the ray depth, we are going to put to 2. So usually most of the things we do for reducing the render time and being cost effective, we don't put the diffuse and specular more than 1. Not in the case of specular, because if there is a multiple reflective objects, we need more specular bounces. But usually we leave the diffuse into just 1, because the bounces after 1 is very low in energy and it doesn't really produce any difference onto the indirect information. So usually we leave it as 1. But here I usually put it on 2 on both of them. Transmission, we don't have any, but still, since we have put the samples on to 0, it doesn't make any difference whether we put any number in here or put it on 0. It doesn't make any difference. So that's our basic sampling settings. We don't change any of these things. Leave it as it is. Maybe you want to turn this option off, auto convert to textures to TX, so that you have a manual control to which textures to convert to TX or which not. So I'm gonna leave it as off, and I'm already added these couple of AOVs onto it. It's just diffuse albedo, diffuse direct, diffuse indirect, specular direct, and specular indirect. This is the basic AOVs which I need to use for calibrating the exposures of the lights, just like we have done in the look dev rig with HDRI tutorial. There is nothing more I'm going to add into this. It's just the same process. We have a 0.18 gray value on the gray ball, and we are going to match the same luminance value on the direct diffuse with the diffuse albedo. That's it. So now let's just quickly do a render. Before that, I'm just gonna assign the same gray material of the gray ball onto the object, and you can see the object diffuse albedo value comes to around 0.173, just like the gray ball, and the diffuse direct value is around 0.075, which is in our calculation around 1.5 or 1.5 stops lesser than the actual neutral exposure or the luminance value of that particular texture. So as a fill light, this value is good for me. It gives proper amount of fill onto the object, which is neither too dark or nor too bright, which works for me. And now let's create our first light, which will be our key light. So I'm going to go into Arnold lights, area light. So here the first thing we are going to choose is on what size we're gonna put the area light into. So let's consider the situations, or if you watch the videos of any VFX Studio reels or VFX Studio look development rig reels, you can see they have added area lights onto some kind of softbox setups. And if you also watch some photography tutorials or photography making videos, you can see they also use softboxes to light up the scene. So these area lights kind of acts as, or kind of mimics the same thing, the real world softboxes in our 3D softwares. So as you can say, this is a kind of a softbox. You can use real world softbox meshes to put into the area light sizes. So I've checked some softbox sizes on the internet, and I've selected 2 different sizes of softboxes for fill and key. So for the key light, we are going to use 48 by 36 size softbox, which is 48 in width and 36 in height, and we are going to put the scale Z into 50. The next thing is we are going to create an aim locator for the lights, so that when the character is small, just like adjusting our camera angle, we can just put the locator down onto the characters so that the light will automatically aim onto that object. Also, it will automatically adjust its exposure. If it is too high, you can move down the light. It doesn't going to affect the exposure. It doesn't going to affect the shadows. So that's the idea. So let's just quickly create a locator. I'm going to name this locator as LGT lock, which means light locator. And I'm also going to scale this to a particular scale, and I'm just gonna put it right on the forehead of this character, so that we are going to measure the light exposure from the character's forehead. So yeah, we have placed it exactly in the middle. Done. So from this thing onwards, the things I'm going to do is exactly as it in the thing in the tutorial constant exposure light with expression in Maya. I'm going to add an aim constraint from the light to the locator, and then I'm going to add a distance dimension shape, and I'm going to put the distance dimension to measure the light distance from the locator, and I'm going to add an expression. So if you guys haven't watched that tutorial, just click on the link and watch it. So our setup is ready for the key light. Let's position it now into a particular area. So this is like a 3-point lighting setup. So we put the key light onto any of the area which is 45 degree to the character, and we're gonna put it into a particular height which is like 2 or 3 feet higher than that character, so that we get this light from a particular height, not like on the same height. This is a better choice for a good dimension, I guess. And now we are going to adjust the exposure for the light. So this is already hitting on the left side, so we are going to measure the pixel values from the right side of the character, sorry, not the left, right side. So you can see if here EV shows around minus 0.56, so we are going to add the exposure to 0.6, and Still its RGB values is around 0.14915, so I'm again adding it to 1, almost close, 0.175, so 1.2. Yeah, we are getting a value around 1.18 to 0.19, which is good for me. So 1.23 is a good value. So our first light is set. Now if you find it hard to position where to position the light, just look at the nose shadow. Make the shadow a little bit lower than the nose, not the exact line as the nose. So that's all the thing we have to do here. Don't put it like very high like this, because then it may cause some problem or when we do the turntable renders on this object. So keep it on a sweet spot, like a 45-degree angle, I'd say. Okay, so even this, you can adjust this light's position according to your need, because we are already done the expression and we have already aimed it. So wherever you move this light, it's gonna cast the same exposure and it's gonna cast it onto that particular point. So no need to worry about this. You can place it wherever you want according to your need. What I'm showing here is a base setup, remember. So I'm going to do the next light. Again, an area light. The second light size would be 72 and 54. Now I'm going to do the same setup for this light too. So our next setup is also ready, the second light, and I'm going to place it on the next opposite angle, which is again 45 degree to the right of that character or left of that character. So yeah, you don't have to make it so accurate. It's not about that, because you can kind of make it like make it onto a 45. Now the next thing is keep it on a particular distance. I'm going to choose a 10 feet distance from that particular asset. So 10 feet means 300 centimeter on the distance dimension. So I'm going to move it on the object orientation. So just about 300. Yeah. So this one light, you can see I haven't moved it onto the top side, because this acts as a fill light that covers or fill the shadows that's been created by the key light. So I'm gonna keep it lower than the fill. So let's just hide the key light and now just calibrate our second exposure. So I'm going to just add 1.2 here straight. So we just used that value before. So let's, if it's the same, it's on the same distance and the size, the exposure doesn't change with its size. So it has to come close. See, it is already close, but still I'm going to add that 1.23. So yeah, we are getting some values above 0.18. I'm gonna round it up to 1.25. So yeah, I'm satisfied with this one. So let's see how it looks with all the three lights. Okay, yeah, we are getting a good amount of speculars, good amount of light, good amount of contrast. The shapes are really visible on each of the part, like this one. That's the best sign. And one final thing is we are going to add our last light, which is the third light on the 3-point lighting, which is a rim light. I'm gonna add another area light, but this time I'm going to use the shape as a disc. And one thing I forgot, I'm also adding samples 3 on the lights, and samples going to change according to each asset, because some of them will have really glossy speculars, some of them have really rough speculars, so we'll have to change according to the subject's shader properties. But as a baseline, we are going to add samples 3 into all the lights. So I'm gonna put the scale to 10 for this one. Let it be hard lights with some hard shadows, so that even if the object has really rough specular values, when this light comes in the turntable, we will hopefully see some specular breakups or something on even that particular object too. So because these two lights are really have a bigger size on it, so it produces comparatively softer shadows and softer speculars. So we need some hard lights like this one. Now the same thing for this one too, in constraining and distance dimension expression. So our rim light is also ready. We are going to place it exactly opposite to our fill, like 180-degree opposite. So even this one we are going to choose a 300 value, even on the fill light. Let's put it 300. Okay, now you can see on the value the light is penetrating onto our background plane. So we are going to move the vertices of that background plane a bit back. So let's just group all the lights into a group called light groups. So let's just try rotating the lights, see if we are not penetrating it with our ground. So it's not penetrating, but still it's really close, so we have to move it again a little bit further. Let's add some loops here. Okay, so let's see if the top part is still enough. Yeah, the top is enough, but see, there is still comes a gap. Yep, our setup is now ready. And one more thing, if you want, you can add a softbox texture onto our lights color. So it's just a flat white color softbox texture which is going to give some variation on the light. It's not going to be really visible on the light or the object. It's really not going to make any bigger difference on the light variations or anything. You are not going to see any bigger difference, but still you can prefer to add some lights. So since we changed the shape of the area light to disk for the rim light, the texture won't work on the rim light, but we can add textures on the area lights. So we can add a file on this, and we can choose the softbox here. This softbox I have downloaded from sibl.com. I'll put the link in the description. You can download it from their site. So I'm gonna add the same texture into my other color also. So we don't have to use two different textures in here. We just need one texture. So let's just again see how that looks now. So one thing we forgot is we forgot to calibrate our rim light before putting it down in that particular position. So let's just bring it on the front, and let's just hide all the other key and fill lights. Now just take a render and calibrate. So we are not putting the key light or fill light onto one exposure higher or one exposure lower. We are putting all the lights into a zero exposure, which is neither underexposing or overexposing the object. So let's just put 1 on the exposure. Let's calculate, read the values. Closer, 1 point. Let's just put the 1.23 value here also. Yeah, it's working good. Let's just put it back where it was before. Yep. So now let's just save our file and let's just do a render now. So we are getting our rim light, our fill light, our key light, and our environment light. All together we are getting this particular setup. So we have finished setting up our basic setup for the look dev rig with area lights. Now one additional thing we can do is, we have discussed this thing on the look dev rig with HDRI tutorial, that even we are using a particular HDRI on the or any set look dev rig setup or lighting setup on the look dev, it is important that we check the shading consistency on many other different lighting situations. So in this situation we can also use different HDRIs on the environment light to just check the shader consistency on different lighting situations. So now I'm going to show you how we can set up multiple HDRIs on the same single dome light to check the shader consistency. So for that I'm going to node editor and just add the light environment light shape here. So you can see we already have our fill HDRI set up here. So for adding multiple lights or HDRI images onto single environment, I am going to use an AI switch. We are going to add different multiple HDRIs onto all these inputs, and according to the index number, the switch is going to select one of the input and it's going to connect it onto the environment. So I'm just going to add the switch to the environment shape and I'm going to select the first HDRI onto the input 0. So when the index is 0, it's going to render our first environment here. If we change the light into 0, you can see there is no input on the 0, so it goes black. So we are going to add another HDRI. We are going to add multiple HDRIs into our environment now. So these are the HDRIs that I have selected for adding it into the look dev setups for checking the shader consistency. So if you see here, we have different lighting setups like sunny HDRIs, overcast HDRI, again a mid-level overcast or sunny HDRI, a night HDRI, an interior night or single light HDRI, a color casted HDRI, a studio setup, an interior with hard lights, an interior with a soft light. So it's not necessary that you test all these HDRIs all the time. You can use these kind of these HDRIs according to your needs. Maybe a particular asset is going to be used in the shots on a sunny or just on an exterior sunny and overcast lighting situations. So we just need to test it how the object properties are coming on only in the sunny and overcast HDRI. Maybe some other asset is going to be seen on the interior with interior artificial lights like filament or bulb or tube light. So we can choose some lighting situations like this one to test the consistency. One thing we are not going to do here is we are not going to exposure calibrate this one, because we need to see how the shaders are working in that particular environment with its raw light information. So we are just going to add all these lights onto Maya and Arnold. So I have already numbered it, so we just place it according to its number. and just quickly add one by one into the input. So when we are testing these HDRIs, you should not use the other lights like key light, fill light and rim light. Just turn it off, and then you can even hide the ground if you want to do the testing with the HDRIs. So it's your choice. So this is our sunny environment. This is our overcast. This is another overcast. This is a night scene. This is an interior with single light. This is interior with soft window light. Interior with multiple lights. A studio setup. And last, a really color casted HDRI. So our setup is now complete. Now let's arrange our outliner a bit. So our reference balls has namespace on it. Okay, reference balls, render cam, light locator. Let's just group the distance dimension shapes together as distance group. Now let's put it all together into the main control group. Now let's just freeze transform character scale into 1. Let's just say our character is on a scale of 10. So what we can do is, before putting all the things into the main control, you should make sure that our locator scale is also freeze transformed into scale 1. Now let's add it back onto the main control. So if our character is on a scale 10, we can put our main control scale also into 10, and if you render it again, okay, let's just turn off the camera visibility here, and I'm gonna increase the max clip plane so that our ground is visible. So let's just save this one and then put the character back to 1, rig back to 1. Let's see how, you can see there is no change in the light exposure, there is no change in the camera angle, there is nothing changed. So the scale change is going to visible more on the properties like triplers or scatters. Other than that, there will be slight changes or modification of the shadows, but it won't be really visible that much. So that is the benefit of our rig. We can scale it according to our need. Now next thing is we are going to add some I hate seeing this locator on the sky dome locator on the viewport. Okay, let's just do the turntable. So if you want to do the turntable animation for the character, usually what we do is, if the turntable frames are 100, first 50 frames our character will rotate, and the last 50 frames, that is 51 to 100, the lights will rotate. That's how a turntable is made. So we can put a locator for the character again. So any character comes, you can just always key the locator and just add the character inside the locator, so that we don't have to key on the character. Just putting it on inside the scale, it will rotate itself. And now we can put the light group and come to the frame 51, put a key. Then on frame 100, you are going to put -360. So the rotation always preferred to be clockwise, not the counterclockwise. That's why I have put the -360. Now the next thing is, if we come to Windows, Animation Editor, Graph Editor, you can see our animation is now has this curve shape. We don't want the animation to have this ease in, ease out interpolation. We need a linear curve. So just select the keys and just click this button. This is the linear tangents button. So let's just check how the render is coming. You can see first the character is rotating, then our light rotates. So in this way you can see how the speculars are working. Is there any flickers on the speculars? Is there any bump that is creating any flickers? Or if the scatters are really working proper, the transmission is working proper, you can have a better understanding on the turntable renders. So this is our basic lighting setup. So guys, before winding up, I want to talk a few more things about the renders which I have already rendered with this light rig, and the thoughts I had when I was rendering different objects with the same lights. So let's just start with the Hulkbuster. So this was the first asset which I have rendered or did the look dev from start to finish in this light setup. So most of the times the things or the assets which we are going to do the look dev is going to be a dielectric material. Normally almost 90% of the things in the world is dielectric, which has basically a diffuse color and a specular. So it is very rare times we will have something like which has properties like triplus, scattering or transmission. From this asset's point of view, I was pretty satisfied with the rig because this was mostly painted metal. The red part is a painted metal and the yellow part is a gold plated. So yellow part is a bit metallic and the chrome or iron part is metallic. So in this case, it is not a fully reflective or fully glossy object. It has a bit of specular roughness and there are a lot of breakups in this speculars. So for this asset, the contrast of the light rig was enough and it was great. The render output was really awesome. So even after that, when I tried testing the same asset in our second HDRIs, you can see the light setup or the shader is working really fine on these HDRI lights also. So the shader was acting as expected on each of the light. In the sunny environment, the speculars were really overexposed, and when I was rendering it on a overcast HDRI, the speculars were a bit rough. So in this asset, the shaders were really accurate and the output was just as expected. And when I did a render for the skin, the thing I felt was the whole 4 lights were flattening the overall skin, and I wasn't getting enough contrast on the skin. I wasn't able to find the scattering feel of the skin with all of those lights. And this render you are seeing here is rendered with 2 lights, the key light and the environment light. Still, I feel like it was missing the contrast that I needed or to have that skin feel. So on this asset, what I did was I rendered the asset with only the key light. So in this way, I was able to get the accurate calculation on the triplus and everything. This is not a shader which I have created in this light trick. This was a project which I have already done earlier, and I was just trying to see how the shaders are coming on this particular light trick. I wanted to see how the skin shader is coming on this particular setup. So for the skin shader, I kind of feel like we need a particular contrast higher than our light trick to have that scattering properties to really show up or to be visible more. So what you can do here, you don't have to change the whole setup or anything, because it's just a few simple things that you can do. The contrast is getting flattened because of the HDRI light, the dome light we are using. And the thing you can do is, when you want to adjust the contrast of that particular light rig, you can reduce our environment lights exposure by 1 stop or half a stop, then add how much value you have reduced from the exposure, add the exact value into the other lights, so that our total exposure will be accurate and the textures of the object will not be underexposed. So that's an easy thing that you can do in this light rig itself, just by changing only the exposure. So that was the thing I found out when I was trying shading with the skin. And the third thing was this car render. And when I was rendering this car, what I felt was, although the whole metal parts are all in a single shader and this is a chrome shader, because of this grayish environment HDRI which we were using as a default, some of the chrome parts were coming a bit flat, and although it has really glossy specular roughness, I was feeling like the environment which is getting reflected onto that part was giving the feel that it is a more rough material. And also if you look at the bumper and the glass frame also, you'll have the feeling that it is a gray dielectric shader. So the reflections are causing it to have that feel of a dielectric shader than glossy chrome. So in this case also, what I would suggest is, if you're rendering really glossy chrome or any metallic shaders, if you feel that you are not getting enough that glossy feel for that particular shader, it's because the environment which is reflected on the particular object is really bright gray, or it is brighter than it should be. So try reducing the exposure of that environment light and compensate that exact exposure on the key light or field light, whatever lights you are using. So in that way you can change the contrast of your light rig. So if you think that changing this contrast is wrong, there is nothing wrong in it. The light exposure will be always accurate. You are just creating a particular contrast so that some shaders properties are more visible to us, so that we can get a better judgment on that particular shader. So that's the only thing that we are doing in this particular cases. And most of the cases, so small assets like this chair is not going to show that much problems in this, because I didn't feel like I needed to change anything on this particular shader. So it was by default coming pretty good. So most of the time you are going to get a beautiful renders and also accurate shaders with this light rig. But there are some points which you may feel like this is lacking some contrast or something. That's the only thing that you're gonna feel in some cases. So this is the solution. It's a simple solution. You can do this. And finally, having a good light rig does not going to get you a better results. There are a lot of advanced rig setups that you can see in the internet, and you're gonna think that those kind of things are going to get better results with those settings. But the fundamentals are all the same in any rig. It's just they add some extra textures or models into it, like a stage. It just gives you a better look. The look dev is not about it's not about making the render look better. It's more like making the shaders accurate, and that depends on how good you are in the look development and how good your observations are, how good your knowledge and skill level is. So the rig gives you just an environment or a platform to create the shaders. So always improve your observations, your knowledge and skills. It's not rig that makes good output, it's you. So I hope you enjoyed this tutorial. If you did, give a thumbs up and leave something in the comment. It means a lot. Share with your friends who are also interested in lighting and look dev. I'll see you with the Hulkbuster look development tutorial next. Till then, this is Swats signing off. Bye.